In general, work depends on the path taken. This is in agreement with our everyday experience. Do you think you need the same amount of energy to push a heavy box from A to B along the blue path and along the green path? However, for some special type of forces, called conservative forces, work is independent of the path. It only depends on the initial and final positions. And if the path is closed, that is, the initial and final positions are the same, then the work will be zero. The force of gravity is a well-known conservative force, while the force of Earth resistance is an example of non-conservative force. When the force is conservative, we can obtain the value of the work done just by solving the integral of the scalar product of the force and displacement for the initial and final positions. According to Newton's second law, we can express the force in terms of the mass and acceleration. We can then use the definition of acceleration as the change in velocity over time to rewrite the integral in terms of the velocity. Solving the integral for the final and initial positions, we obtain this expression. The product of the square of the velocity and the mass divided by 2 is what we call the kinetic energy of the system. It is the energy due to an object's motion. So, under conservative forces, the change in kinetic energy of a moving object is equal to the work done on that object. This is known as the work-kinetic energy theorem.